So today we're only in chapter 2. We're only going through section 2.6. So I know that I believe there's a 2.7 and a 2.8, but we're not going to cover that. We're only going to go through the 2.6. So section 2.6, and we're going to do it today and tomorrow. So if we want to, we can call it 2.6a. Has to do with rational functions. And their graphs, if you want to add that on there, right? Because we're going to look at their graphs. Because we know that when it comes to our test, we're not using graphing calculators, so we want to be able to look at these functions and figure out how to graph them without the use of calculators or graphing applications, all that kind of good stuff, right? So to start with, what does it mean to be a rational function? So if something is rational, it means to write it as a ratio. And really all a ratio is, it's a fraction, right? It's a number to a number. So we want to be able to write our function as a fraction. And then in the numerator is going to be one function, and then the denominator is just going to be another function. So our fraction is just going to be a function over a function. So we have, I think today, we need to be able to find the domain. We need to be able to look at asymptotes. I'm going to give you guys the graph. Tomorrow we're going to learn how to graph them so we can come up with this thing called an arrow notation. So those are kind of the three things that we're going to kind of cover today. So the first thing we want to be able to do is to find the domain. And we know that the domain is our x values. And this is going to be important when it comes to rational functions, because that denominator is a function. So because it's a function, it means that there's going to be a variable in there. And we know that our denominator can never be 0. So there's got to be values of that x term or whatever our variable is that might make that denominator 0. And so we need to find our domain so we do not include those numbers that are going to make our denominator 0. So let's say we had the function, I don't know, let's just stick with f of x. Whoops, sorry about that. So let's say we had f of x equals x over x squared minus 9, right? So we have to be careful when it comes to our mathematics, making sure we know proper algebra and canceling. When it comes to these, like when you want to be able to cancel numbers out of numerator and denominator, like 5 over 5, we know that reduces to 1. On this function, we cannot cancel out our x's because they have to be factors, and factors are things that you multiply by. So make sure we're being cognizant of that. So I know that I have to look at my denominator, because my denominator can never equal 0. So I need to find the values that are going to make that denominator 0. So you have two choices. You can either factor this and then set it equal to 0, or I'm just going to jump right ahead and set it equal to 0 and see if I can solve it for x. So to find out, I'm going to go with x squared minus 9 equals 0. Granted, we're trying to find those values so that we know that it's not going to equal 0. But so then we're going to add 9 to both sides. X squared equals 9. We're going to take the square root, and we're going to get x equals a positive or a negative 3, right? So if you do it this way, the biggest thing to remember is the fact that you're going to get that positive and negative 3. That's why sometimes if you were to factor that, this is a perfect square, and that negative means it's a difference, so it's the difference of perfect squares. So you would have x plus 3, x minus 3 equals 0, and then when you set each one of these equal to 0, you're going to get x equals -3, x equals a +3. So you're going to get the same answer. I'll say, like, usually when you go ahead and factor, there's no way of getting around getting that positive and -3. The mistake that happens here is when you take the square root of both sides, is sometimes you forget that you have to take the positive and the negative, right? Because a -3 squared is also going to be a +9. So now when it comes to our domain, we know that that +3 and that -3 is what's going to make our denominator 0. So we can't have those in our domain, right? So we know that for our domain, x cannot equal -3 and 3. So we like to actually write this in a form called interval notation. And we've done this one before. This is where we're using the parentheses, right? So when it comes to our domain, we want to know all of the x values that we can be, not the x values that we can't be. We want to know the values that we can be. So we know that we can start off at -infinity. Love my infinity symbol sometimes. And we can continue on -infinity until we get to -3. And we can't be -3, so we're going to throw another parentheses around it. And we're going to give our little union, because our union, right? And then we're going to go from -3 all the way until we get to 3. And again, we can't be those, so we're going to put parentheses around it. And then the union, then we can go from the 3 all the way until we get to infinity. So this is telling us what our domain actually can be. So what happens at our graph then when we actually get close to where x is 3 or when x is -3? Anybody got any ideas on what that thing was called? I'm just going to scroll to the next page a little bit. So that's telling us where our asymptotes are, right? So if I were to do a graph, and I came up with, let's go with 1, 2, 3, 4, 5, 1, 2, 3, 4, 5, 1, 2, 3, 4, 5, 1, 2, 3, 4, 5, right? So we knew that when x was 3 and -3, our graph cannot exist because it's undefined at those two spots. So at this -3 and this 3, we can't have any values for that. So those are called our asymptotes. So usually what we do, remember, we draw our little dashy lines that say that we can, and since when it came to our asymptotes, we were talking about the x values, we know that it's got to be a vertical asymptote because it's talking about x. And if I'm talking about x being, 3, well, the only way where x is 3 is all the way up and down this line, right? There's no other place where x is 3. So that's how we know it's going to be in an asymptote. So when it comes to our domain is going to find our vertical asymptotes. And we remember what an asymptote means, right? So you can get really close, but you can't touch it. You can't touch it or go through it, right? And then we know on this one, this is our vertical asymptotes, right? Because we were talking about those x values from our domain. So our vertical asymptotes are when x equals -3 and when x equals a +3. And I know you're dying to wonder if there's these things called horizontal asymptotes, and there are, and we're actually going to talk about those tomorrow. So tomorrow we're actually going to be able to put all of this stuff together and be able to graph any and all functions and know our horizontal asymptotes, our vertical asymptotes, all that good stuff. Sound good? All right. So I'm going to jump ahead and I'm going to actually graph this for you guys because I want to talk about this thing called arrow notation. And if you guys are going onto onto calculus, that arrow notation is used a lot, if not constantly, within calculus. So they want you guys to get introduced to it now. So tomorrow we're actually going to learn how to graph this function, but I'm going to go ahead and graph it for you for today. So this function, our x over x squared minus 9, graphs like this. It actually goes through 0. Oh, I hate drawing these ones. There it goes. This way. And it's going to be up here like this, right? Perfectly drawn, right? Like always. So you guys will be doing that one tomorrow. So when I talk about our third thing that we want to talk about, which is our arrow notation, it's going to explain what the graph is doing as it gets to these very important spots. So what happens to our graph when it's going to a negative infinity, when it's going towards positive infinity, and what's it doing on either side of those asymptotes? So ultimately I want to talk about, like, as I'm going to infinity, what is my graph going to do? So on this problem, that would be like number 1, right, towards infinity. And I'm going towards infinity from my negative, I'm going negative like on my x values because I'm going this way, right? So I want to know where it's going towards negative infinity. So that's my first one. Then I'm going to start coming this way and I'm going to get towards this asymptote. And I'm coming from that negative side of the asymptote, right? To the left would be negative, to the right would be the positive values. So I want to know what's happening to this graph as I'm coming to the asymptote from this direction. So that's going to be my second arrow notation. But what happens when I get towards this asymptote when I come from the positive side? So that would be my third arrow notation. And then when I get to the next asymptote, right down here, right, I'm getting towards it from the negative side. So that would be the fourth. And then I want to know what's happening going this way to the asymptote. So that would be my fifth arrow notation. And then ultimately then my graph is going to keep going this way and it's not going to hit any more asymptotes. It could hit more asymptotes if that was how the problem was set up, but this one's not. Then you would continue with those. And then I'm going towards positive infinity. So I need to come up with 6 different arrow notations for this problem. Right. So the way we start that, so if we're going to talk about, our x values, right? So as x approaches, right? Let's start off with negative infinity. Right? Try to draw a little better infinity symbol for you. So this is saying as x is going towards negative infinity. Right? F of x, our function, where is he going? What value? So f of x would be our y values. So as this function continues, what y value am I getting really close to? I'm getting really close to 0. Right? Maybe. Just try 5 more and see if we can help out, right? So then what's my next little step that happened? So as x approached, so I'm in this way, so I'm approaching this asymptote, and that asymptote was at -3, right? So as x approaches -3, and then this is the part where, remember I said you can get to -3 from the positive or the negative side, if you're on the left or the right. So we're going to start by coming from the left, so this is going to be the negative side. So the way you denote that is kind of like up in the exponent, you're going to write a little negative sign. So that's telling you that you're approaching -3 from the negative side. F of x is going to go where? F of x is our y values. So as I'm getting closer to this asymptote from the left, what's my y value going to? It's shooting down, isn't it? So my y value is going towards where? Yeah, -infinity. Right? So looking at that same asymptote, our graph is going to come from the right side, right? So from the positive side, and we got to figure out what's happening there. So that one would be as x is approaching -3, but now since you're approaching -3 from the right side of the asymptote, we call that the positive side of the asymptote, we're going to put a little positive sign up there. We want to know where our y is going, so our y is our f of x. So as I get closer to this asymptote, what's happening to my y value? My y value is going up, right? And it's going to keep going up until it gets to positive infinity. You can either write the positive or just leave it as infinity, right? All right. So now let's keep chucking along our x values, right? So we're going through, and then all of a sudden, oh, we're hitting another asymptote. So we know we can get there from the left and to the right, we just can't be it. So what's happening? So as x is now approaching, we're approaching now 3. Yeah. And we're approaching that from the left side. So what are we going to do? Put a little negative up there. Okay. F of x, or our y value, where's our y value going to go? Well, as I'm going here, oh, look it, he's going down. He's going down to -infinity. Okay. And since we approached it from the left side, we know that we can also approach it from the right side. So as x is approaching 3, but now we want to talk about it from the right side. So that's going to be when 3 is from the positive side. Where's our f of x going? Oh, positive infinity. Right? And then we got one more. Because remember, we're trucking along the x. Oh, and then I can keep going towards infinity, right? So as x is approaching, either put the positive or not the positive, I'm not too picky on that, infinity, f of x, our y value. So as I keep going this way, where is my y value going? It's getting closer and closer and closer and closer to 0. Yep, to 0. I know it's a lot to handle, kind of like in one, it's like, what? But I will say that they do kind of become a little bit easier with a little bit of practice. And the biggest, I mean, on this one is this whole notation of this positive and negative, making sure like when it comes to those asymptotes, you're talking about it from both directions. And then don't forget about your like going towards your positive and your negative infinities. That's probably the other piece that might get missed.